Class 10th Mathematics, chapter number 8, Introduction to Trigonometry. Now in this we learn that the word trigonometry is derived from the Greek words tri meaning three, gon meaning sides, and metron meaning measure. In fact, trigonometry is the study of relationships between the sides and angles of a triangle. The earliest known work on trigonometry was recorded in Egypt and Babylon. Early astronomers used it to find out the distances of the stars and planets from the Earth. Even today, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. In this chapter, we will study some ratios of the sides of a right triangle with respect to its acute angles called trigonometric ratios of the angle. We will restrict our discussion to acute angles only. However, these ratios can be extended to other angles also. So, the angles which will be considering in this case will be consider only the right angle triangle and not other triangles, but trigonometry can be applied to other triangles also, but that is not in our syllabus. So, let us see this figure. We are having a right triangle here, and suppose we consider angle A, then there are two sides, or we can say the arms are there. One is AC, another one is AB. The longest side in a right triangle is known as hypotenuse. So, AC will be the hypotenuse, and the other side, that will be known as base for angle A, and the side opposite to the angle which we are considering, that is the side BC, that is known as perpendicular. So, this is what we have to remember that, and same way it will change here. Suppose we see, let me draw another figure here. Suppose we have say another triangle here. Triangle is same, but I am taking the another uh, angle, say this C, this B, and this A. This is right angle triangle. And suppose we are considering angle C this time, not angle A. Then obviously opposite to 90° will be the hypotenuse. So this is hypotenuse. AC is the hypotenuse, and the other arm of angle C, that is BC, that will be base. And opposite to angle C, that is known as perpendicular. So these things you have to remember, that which is perpendicular and which is base in the context of trigonometry in a right angle triangle. Now, as we have seen here that we have to learn the ratios of the sides of a right angle triangle with respect to its acute angles. So we will be going in that one. So trigonometric ratios of, suppose let us consider say angle A. Now we will consider angle A in a right angle triangle. In right triangle ABC, let us consider angle A. Now we know that the side opposite to the concerned angle is to be taken as perpendicular. So this is perpendicular, and the side opposite to 90° is hypotenuse. So this is our hypotenuse, and the side other than the hypotenuse for which the concerned angle is there, that is to be taken as base. So this is our base. So this is the hypotenuse, and this is perpendicular. Now with the help of uh, these things we will find the trigonometric ratios. So first one is known as sine of angle A, sine of angle A, and in short it is written as SINA, and also to be this to be read as sine A, not as sin A, equal to, do not read it as sin A, it is sine A only, and that is defined as the ratio of perpendicular over hypotenuse. So the ratio of perpendicular over hypotenuse is known as sine of angle A. This is sine A. Now next we will be going for cosine of angle A. Cosine of angle A, and in short we write it as cos A, and it is to be read as, and it is defined as base over hypotenuse. So this is the definition of cosine of angle A. So whenever we take the ratio of base over hypotenuse, it is to be considered as cosine of the angle. So now next we will learn another ratio that is known as tangent of angle A. Tangent of angle A. So tangent of angle A is, so this is our angle A here, or we can consider this figure also. Here also let us write down the same thing. This is our angle A, and this is hypotenuse already given, and opposite to angle A, that will be perpendicular. So this is our perpendicular, and this is the base. So tangent of angle A is defined as the ratio of perpendicular over base. So tangent of angle A, in short we write as tan A, and it is defined as perpendicular over base. Now we have another ratio that is known as cotangent of angle A. Here also it will be there, cotangent of angle A. So we will be writing that one, cotangent of angle A, cotangent of angle A, and we, in short we write it as cot A, and is defined as the reciprocal of tan, that is the ratio of base over perpendicular, base over perpendicular. So this is our cotangent. Now let us take the other one, that is cosine. So we will take the reciprocal of cosine of angle A, and it is known as uh, secant of angle A. So next one will be secant of angle A, secant of secant of angle A. In short we write as sec A, and it is defined as, so this is our figure of the right triangle. So sec A is defined as, what is cos A? Actually secant of angle A will be the reciprocal of this our uh, cosine of angle A. So what is cosine of angle A? That is base over hypotenuse. So reciprocal of this, that is hypotenuse over base. So secant of angle A is sec A, that is equal to hypotenuse over base. So sec and cos A are both the reciprocal of each other. So how is secant of angle A defined as? Is defined as hypotenuse over base. Now next let us go in the other one, that is known as cosecant of angle A. Cosecant of angle A, and in short we write as cosec A, and it is nothing but it is the reciprocal of our sine of angle A. So what is sine of angle A? That is the ratio of perpendicular hypotenuse. So if we take if we do the reciprocal of this, we will be getting hypotenuse over perpendicular. So that is what we will write. So cosecant of angle A equal to cosec A equal to hypotenuse over, this time we will write perpendicular. So this is these are the main trigonometric ratios, and from this we can easily find more results. So let us do that one. What we have seen is here, if we see that tan A and cot A, they both are reciprocal of each other, because tan A is perpendicular over base and cot A is base over perpendicular. Therefore we can say that we have cot A into tan A equal to 1. So this is one result. Another one we can see is that secant A, that is sec A and cos A. What is cos A? That is base over hypotenuse. What is sec A? Hypotenuse over base. So that means they are reciprocal of each other. If we multiply them, we will get 1. So second result is cosec A, not cosec A, it will be sec A, sec A into cos A equal to 1. So we are getting sec A into cos A equal to 1. Similarly, let us take cosecant. That is cosec A. Cosec A is hypotenuse over perpendicular. And if you remember that sine A is perpendicular hypotenuse, let us see it here back. Sine A is perpendicular by hypotenuse, so they are reciprocal of each other. So we will be writing this one as cosec A into sine A equal to 1. And one more we can see that let us find the ratio of say sine by cos, sine, say sine A over cos A. So what is sine A by cos A? If we see here, sine is defined as the ratio of perpendicular hypotenuse. So sine A will be perpendicular by hypotenuse, the whole, divided by what is cos A, it is base over hypotenuse. Base over hypotenuse. So in both we can cancel out this hypotenuse. So the remaining will be getting is equal to perpendicular by base. Now if you remember that perpendicular by base is known as tangent of A or tan A. So here you can see the perpendicular by base. The ratio of perpendicular or base is tangent of the angle. So that is equal to tan A. So we can write this as tan A. So therefore what we can say that therefore tan A equal to sine A over cos A. That means we can write tan in terms of cos, and same way we know that tan and cot, from here tan and cot are reciprocal of each other. So cot A we can write as cot A equal to, because cot is reciprocal of tan, so will be cot A can be written in terms of sine and cos as cos A over sine A. So these are very important trigonometric ratios, which are very important one, and we'll be applying them in the exercises will be coming in this particular chapter. So now let us go in the exercise where we'll be applying these formulas. First one is exercise 8.1. So let us go in exercise 8.1 now. So now we have exercise 8.1, question number 1. In triangle ABC, right angle at B, AB equal to 24, BC equal to 7 centimeter, determine sine A cos A. Second part, sine C cos C. So let us do this question number 1. So here we are, first of all we'll draw a rough figure for this. So this is our solution. We'll draw a rough figure for this. So let's draw a right triangle. So this is the it is given that the triangle is right angled at B. So we will be writing here B. A we can write anywhere we like, either here or here, anywhere. So suppose I write A here and this is C here. And first of all we'll write the values which are given here. AB is 24, so this is 24 centimeter, and BC is 7 centimeter. That means all the three sides are not given. But the third side we can easily find with the help of Pythagoras theorem, because angle B is 90 degrees. So first of all we'll do that one. In right triangle ABC, using Pythagoras theorem we have, using Pythagoras theorem, we have, what we are going to have is AC square is equal to AB square plus BC square. So AC square is equal to, AB is 24, so 24 square plus 7 square. AC square equal to 24 square is 576 plus 7 square is 49. Therefore, we will be getting AC square equal to, if we add them we will get 625, and therefore AC equal to 25 centimeter. So this is the length of AC, that is 25 centimeter. Now we know the definition of sine A, so we can easily find the values. So this is our sine A. Now sine is defined as, how is sine defined as? Here sine A equal to, that is perpendicular hypotenuse. So what is our perpendicular? Opposite to angle A is perpendicular, that is BC, over hypotenuse. So what is the hypotenuse? AC, equal to, now what is BC? 7, and hypotenuse is 25. So 7 by 25 is the value of sine A. Similarly we will find now, so this is our first part. Similarly we will find cos A. What is cos? Cos is defined as base over hypotenuse. So the side adjoining to the angle A other than the hypotenuse is known as base. So in this case base is AB over hypotenuse. Hypotenuse is AC. So putting the value of AB will be getting 24 by 25. So this is the value of cos A. Now next we will find the value of sin C and cos C. So sin C equal to, second part now, sin C equal to, so now we will consider this as our constant angle, and this is not required, so we'll leave it as it is because the triangle is being erased. So sin C is defined as sin C in the same way perpendicular over hypotenuse. So opposite to angle C is the perpendicular, that is AB. AB over hypotenuse. So what is the hypotenuse? AC equal to, that is 24 by 25. Similarly, we will find the value of what we have to find is cos C. So we will find the value of cos C. Cos C is equal to base over hypotenuse. So what is our base in this case? The side adjoining to angle C other than the hypotenuse, that is BC. So BC over the hypotenuse. So what is the hypotenuse in this case? Hypotenuse is AC. So AC equal to, now what is the value of BC? 7. And what is the value of hypotenuse? That is 25. So 7 by 25. So this is the answer of question number 1. So with this, question number 1 is complete. Exercise 8.1, question number 2. So question number 2, in figure 8.13 find 10p minus cot r. So this is figure 8.13 and only two sides length are given, third is not given, but that we can easily find with the help of Pythagoras theorem. So because triangle PQ is a right triangle, so we can use here Pythagoras theorem and obtain the value of QR. So solving question number 2 now. First of all, we will find QR. In right triangle PQR, applying Pythagoras theorem, Pythagoras theorem, we have now opposite to 90 degrees always the hypotenuse, so we can write PR square is equal to PQ square plus QR square. So what is PR? PR is 13, so 13 square is equal to PQ is 12 square plus QR square. So therefore this will give us 169 equal to 144 plus QR whole square, and this will give us 169 minus 144 equal to QR square, and when we subtract this we will be getting 25. So 25 equal to QR square. Therefore QR equal to 5 centimeter. So this is our 5 centimeter. Now we will be finding the value of 10p minus cot r, but before that we will find the value of 10p and then the value of cot r, then subtract them. So 10p now, 10p equal to, so 10p is perpendicular by base, so this is our p. So what is perpendicular in this case? Opposite to the concerned angle is always perpendicular. So in our case perpendicular will be QR. 10p is QR over what is the base? Adjoining side other than the hypotenuse, that is PQ. So that is equal to, now putting the values, QR is 5 and PQ is 12. So 5 by 12. Next we will find the value of cot R. So cot R equal to, so this is our R, and what is cot R? It is just the reciprocal of 10 in definition. So cot is base by perpendicular. So what is the base? Adjoining side. The hypotenuse is base. So here we will be writing, do not write 5 directly. First we will write the name of the side, that is QR. That is base over perpendicular. What is perpendicular? Opposite to angle R. What is the side? PQ. So that is the perpendicular. So QR over PQ. So equal to, this is why we have got this as now base over perpendicular, equal to QR is 5 over PQ. PQ is 12. So cot R equal to 5 by 12. Now what we need to find is 10p minus cot R. So therefore 10p minus cot R, that is equal to 5 by 12 minus 5 by 12, and that is equal to 0. So this is the answer of question number 2. Exercise 8.1 question number 3. If sin A equal to 3 by 4, calculate cos A and tan A. So solving question number 3, solution 3. Sin A equal to 3 by 4, and we know sin is equal to perpendicular by hypotenuse. So this is perpendicular and this is hypotenuse. So now we'll draw a triangle, and let this be A, this be B, and this be C. And what it says perpendicular is, so suppose let us consider angle A. So suppose this sine, because this, we are concerned with angle A, so opposite to angle A will be perpendicular. So this is perpendicular, it will be 3, and the hypotenuse is 4. So this is 4, and we have to find in this case BA, that we can find with the help of Pythagoras theorem. But is this figure correct? This figure is theoretically not correct, because it may be possible, because we cannot say that when we compare this ratio, actually ratio is always in simplest form. It may be possible that the perpendicular is 6 and hypotenuse 8, or it may be possible that the perpendicular is 9 and the hypotenuse 12. So to avoid this problem, what we will be doing here, in this 3 by 4, we can rewrite this as equal to 3k over 4k, where k is not equal to 0. K is actually should be a positive real number, because it cannot be negative, and that is what we'll do here. So we'll write here 3k and 4k. We'll not write 3 and 4, because it can be multiple of 3 and 4. Yeah, this both 3 and 4 can be multiple of, say, constant number k. So that is why we'll avoid writing 3 and 4. Perpendicular will not write as 3 simply, and hypotenuse will not write simply as 4. So that will be writing as 3k and 4k. So now let us continue with this one. First of all, we'll find the value of AB using Pythagoras theorem. So in right triangle ABC, applying Pythagoras theorem, so what we'll be getting is AC square equal to AB square plus BC square, Pythagoras theorem. So this will give us, what is AC is 4k, so 4k whole square equal to AB square. AB is not known to us, so that we will write as it is, plus BC square. BC is 3k, so 3k whole square. So on simplification, this will give us 16k square equal to AB square plus 9k square. Therefore, we can say that AB square is equal to 16k square minus 9k square. Therefore, AB square is equal to 7k square. And therefore, we can say that AB is equal to root 7k, taking square root both sides. So in place of BA, we can write there root 7k. So this is root 7k. Now it will be very simple for us to find our question solution. So what we have to do is we have to find the value of cos A and tan A. So cos A now, what is cos A? Therefore cos A equal to, cos is defined as base over hypotenuse. So let us see what is in this one, what will be getting cos A is A. So base will be AB and hypotenuse AC. AB by AC equal to AB by AC. Therefore, we can say that cos A equal to, so we will put the value of AB and AC. Value of AB is root 7k, root 7 into k. K is not inside the root, and divided by 4k. 4k, and k will cancel out. So the final answer will be root 7 over 4. So this is the value of cos A. Now we have to find the value of tan A. So tan A equal to, tan is defined as perpendicular by base, perpendicular over base. So that is equal to, we'll see in the figure what is perpendicular. Perpendicular is the side opposite to the angle A, that is BC. So we'll be writing BC over, what is base now? Base is the side adjoining to angle A other than the hypotenuse. So that is root 7k, that is AB. First we'll write AB, then we'll write its value. Therefore, tan A equal to, now we'll write the value of BC. So what is the value of BC? BC is 3k. So equal to 3k over, and what is AB? AB is our root 7k. So root 7k, k is not to be written inside the root, and k cancel, so equal to 3 by root 7. So this is the answer of question number 3. So with this, question number 3 is complete. Exercise 8.1, question number 4. Now question number 4 is given 15 cot A equal to 8. Find sine A and sec A. So this is similar to the question number 3 which we have done. So what we'll do is, here first of all write the value of cot A. So cot A is 8 by 15. So let us solve question number 4. 15 cot A equal to 8. Therefore cot A equal to 8 by 15, and cot is defined as base over perpendicular. So now we cannot say, that the base is 8 and the perpendicular is 15. It can be or it may not be. So it can be even a multiple of some constants. Say this can be 16 and 16 by 30 also, because ratio is always written in simplest form. So what we'll be writing here is equal to 8k over 15k, where k belongs to r plus, that is k is a positive real number. Now we'll draw a rough figure for this. So we'll draw a right triangle, and what angle is given here, A. That means obviously A is not 90, so we can write A here, or we can write A here also. So this is our B, and C I am writing here. Now we know what is base. Suppose, because we have to take angle A under consideration, so other than hypotenuse, the side which we are having is known as base. So in our case, base is 8k. So this is our base. This is the base, this is the hypotenuse, and this is the perpendicular. And what is the perpendicular? 15k. So this is 15k. Now what we need is, we need the value of AC. So we can use Pythagoras theorem in this case. So we'll be applying Pythagoras theorem in right triangle. In right triangle ABC, we have we have AC square is equal to AB square plus BC square. This is by Pythagoras theorem. And AC square will be equal to, what is AB? Our AB is 8k. So 8k whole square plus BC. What is BC? 15k whole square. BC is 15k, so BC square is there, so we are writing here 15k whole square. And now we'll simplify this. So we'll be getting AC square equal to, this will give us 64k square, plus square of 15 is 225, so 225k square, and on adding we'll be getting AC square equal to, it's become 5 plus 4 is 9, and 6 plus 2 is 8, so we are getting 289k square. And if you see the square of 17, that is equal to 289, therefore we can say that AC equal to 17k. So AC equal to 17k, and let us write that 17k here. So 17k, this is 17k. Now what we have to do is, this is 8k, this is 17k, and this is 15k. So we have to find the value of sine A and sec A, and we know by definition how sine A is defined as So sin A equal to is defined as the ratio of perpendicular over hypotenuse. So equal to, now what is our perpendicular? Perpendicular is the side opposite to the concerned angle. So that is, in our case it is 15K, or we can say BC, equal to BC over, what is the hypotenuse? Hypotenuse is AC. Next we will be putting the value of BC. So the value of BC, if you see the figure, is equal to 15K. So that is 15K, and AC we have obtained as 17K. Now because K is a non-zero real number, positive real number, so cancelling it out, we are getting sin A as 15 by 17. So therefore sin A equal to 15 by 17. Next we have to find is sec A. What is sec A? That is equal to hypotenuse over base. So we will be finding the value of sec A now. Sec A equal to hypotenuse over base equal to. So now let us see what is the hypotenuse. Hypotenuse we can write from here, hypotenuse AC, and what is the base? So the base is the adjoining side other than the hypotenuse, that is AB. So AB is the base, so we will be writing here AB, and value of AC from here, it is 17K. So 17K by AB. So let us see the figure. What is the value of AB? Value of AB is 8K. So we will be writing here 8K. Again, K is a non-zero positive real number, so we can cancel it out. So therefore we can say that sec A equal to 17 by 8. So this is the answer, and this is the value of sin A. So with this, question number 4 of exercise 8.1 is complete. Exercise 8.1, question number 5. Given sec theta equal to 13 by 12, calculate all other trigonometric ratios. All other trigonometric ratios means there are 6 trigonometric ratios. Already we have seen that sine is there, then cos is there, tan is there, and that 3 reciprocals, total 6. So here 1 is given, sec theta is given, and we have to find the remaining 5. So let us start doing this one. So solving question number 5 now. Solution 5. Sec theta equal to 13 by 12, and sec is defined as hypotenuse over base. So this is hypotenuse and this is base, and already we have discussed that whenever ratio is given, we will be taking it as 13K over 12K, where K belongs to R plus. So let us draw a right triangle for this. So this is the right triangle. So let us take this as A, this is B, and this is C, and this we can take as theta, and this is our 90-degree angle. So hypotenuse is 13K. So this is our hypotenuse, that is 13K, and the base is 12K. So adjoining to the sides adjoining to theta, other than the hypotenuse, is known as base. So base will be BC, and so we'll be writing here 12K. Is 12K, and we have to find now, we will be finding the value of AB, and that we can do with the help of Pythagoras theorem. So in right triangle ABC, we will apply Pythagoras theorem. In right triangle ABC, AC square equal to AB square plus BC square, that is by Pythagoras theorem. So this is Pythagoras theorem, and just we'll put the values from here. So AC is 13K, so we'll be writing here 13K whole square equal to AB as it is. So AB square plus BC is 12K, so 12K whole square. This will give us square of 13 is 169K square equal to AB square plus 12K whole square is 144K square, and simplifying this, we'll be getting 169 k square minus 144 k square equal to AB square. Therefore, we can say that AB square is equal to, subtract these, will be getting 25. So 25 k square. Now taking square root both sides, will be getting AB equal to, therefore AB equal to 5k. So here we'll be writing 5k. So now it is very simple for us to get all the trigonometric values which we want. So we'll be finding them. Now sec is given to us. We can easily find the value of cos theta, because we know that cos theta is the reciprocal of sec theta. So that is what we'll write. Since sec theta equal to 13 by 12, therefore cos theta equal to reciprocal of that is 12 by 13. And now let us write down sin theta. Sin theta equal to, also sin theta equal to, that is perpendicular by hypotenuse. What is the perpendicular in this case? So first let us write down the formula here, the way it is defined. Perpendicular by hypotenuse. So that is equal to, what is the perpendicular? The side opposite to theta, that is AB. So we'll be writing AB over AC, because AC is the hypotenuse. So AB over AC, and therefore we can say that sin theta equal to, what is AB? Let's go back to the figure. AB is 5k. So 5k, and what is AC? That is 13k. So 5k over 13k. 5k over 13k, and k being a positive real number, it can cancel out. So final answer we are getting is 5 by 13. And we know that cosec is nothing but the reciprocal of sine. So therefore we can say that cosec theta is equal to 13 by 5. Next we will find the value of tan theta. Tan theta is defined as perpendicular by base. So let us again revisit the figure. So what is the perpendicular opposite to the angle theta side? That is AB. And what is the base? Base is BC. So AB over BC equal to AB over BC, and equal to, we will be putting the value of AB, that is 5k, and BC is 12k. So 5k over 12k, 5k over 12k. Again, k being a non-zero real positive real number, we can cancel it out. So what we have got is tan theta equal to, therefore we can say, therefore tan theta equal to 5 by 12. And we know that tan and cot are reciprocal of each other, so we can get the value of cot theta also. Therefore cot theta equal to 12 by 5. So this is the answer of question number 5. So this question number 5 is complete.